Hi, today we'll continue with square roots and we'll study something called simplest radical form. Now, example, write in simplest radical form. And what we have to write in simplest radical form is square root of 32. And now, simplest radical form means that you have the smallest possible number under the square root. And you will get that by looking for the largest perfect square that divides the number under the square root, so 32 in this case. Perfect squares are numbers that are squares of integers. For example, 2 squared makes 4, 3 squared makes 9, 4 squared makes 16, 5 squared makes 25, 6 squared is 36, and so on. And now we should look for the biggest perfect square that divides 32. Well, 32, you can divide that by 4 because 32 is 8 times 4. You can't divide that by 9, but you can divide that by 16 because 2 times 16 is 36. And you can't divide 32 by any of the bigger perfect squares. So the biggest perfect square that divides 32 is 16. And you can express 32 as 16 times 2. So factorize the 16 for the 32 for 16 and think about what multiplies the 16 to get the 32. It's 2 in this case. Now, then we know that we can take the square root separately from the numbers under the square root if we're multiplying the numbers. So we can do this. And now, the perfect square, the largest perfect square that divided 32 in here, is now under its own square root. So we can take a square root of that, and square root of 16 is 4. And square root of 2 is no integer, so that just remains as it is. And the answer is 4 square root of 2. So square root of 32 is the same thing as 4 times square root of 2. And that's the simplest radical form. Second example. Write in simplest radical form, and especially in the form of a plus b times square root of n, where a and b are rational numbers. So they can be expressed as numbers that can be expressed as fractions, so integers or fractions, and then n is an integer. Now, first, we'll start by writing in simplest radical form the square root that we have over there, so 45. And to do that, we'll look for the largest perfect square that divides 45. So when looking at this, the largest perfect square that divides 49 is 9. And 49 is the same thing as 9 times 5. So I skipped one intermediate step in here. I already took the numbers under their own square roots in here. So square root of 49 is the same thing as square root of 9 times square root of 5. And now square root of 9, that's easy, that's a 3, so we can replace that by 3. Then we were supposed to express this as a number times a square root. And we don't have any denominators in here. We do have one in here, so we need to get rid of that. We can divide all the terms by 3. So we'll have 6 divided by 3, that's 2. 3 square root of 5 divided by 3, that's 1 square root of 5. And 3 divided by 3, that's 1. And now 2 plus square root of 5 over 1, that's the same thing as 2 plus square root of 5. And now it's in the form that was required. So our a is 2, b is 1, because we have 1 times, and n is 5. The last example. Now, express with integer denominator. So in the denominator, we have a square root to start with, but we would need to get rid of that square root. How do we do that? We can get rid of the square root by expanding the fraction by square root of 7, by the denominator that we had in the denominator. So multiply both numerator and denominator by square root of 7. And then 3 times square root of 7, that's just 3 times square root of 7. And then you would have square root of 7 times square root of 7 in the denominator. And now we'll remember that square root of 7 times square root of 7, that's a 7. And now we have an integer in the denominator.